Now we've had the opportunity to check whether or not a point was a solution to a system of equations. Now we're actually going to solve using various methods. So the three methods I want to focus on with you are graphing, substitution, and elimination. We'll learn a few other methods in our next module. But in this one, if I'm solving by graphing, I would start my first line at -6. I would use my slope of -3/1 to go down 3 to the right one or up 3 to the left one as many times as I needed to. And then of course I would connect the dots. Try to use a straight edge. For my second, this is obviously not in slope-intercept form. It's in standard form, but using the cover-up trick probably wouldn't be great because I'd end up with a fraction. So I'm going to manipulate this equation to turn it into slope-intercept form to make it easier for me to graph. And I'm just going to move that 2x to the opposite side, and then I have to take everything divided by -1 so that it's positive y. So I have y equals 2x minus 1. So up 2 over 1 or down 2 to the left 1, and I can see that the point at which these two cross is -1, -3. That's my solution to the system. Now keep in mind that we're going to do this same example using all three methods, so remember that this one was -1, -3. For my next, my first equation, I would start it at -2 since it's in slope-intercept form. 1/2 means up 1 over 2, that's rise over run, rise over run. Connect the dots. For my second equation, this is in standard form. I could turn it into slope-intercept form, but I'm going to use the cover-up trick. So I'm going to cover up 2x, which leaves me with 4y equals 8, or y equals 2. And then I'm going to cover up 4y, which leaves me with -2x equals 8, or x equals -4. Plotting those 2 points and connecting the dots, I can see that those two lines are parallel and therefore will not cross each other. This is a no solution question. No solution. Also inconsistent. For my last one for graphing, again, this one I would start at +2. My slope is -1/4. Remember, when there's a negative, we either put it on top or on bottom, but not both. So it'd be down 1 to the right 4 as many times as I need to. And then for my second equation, I would probably use the cover-up trick. So I would cover up x and get 4y equals 8, so y equals 2. And I would cover up 4y and I would get x equals 8. And I can see that this is the same line 2 times, and so this is infinitely many solutions. This is also called consistent and dependent. Now I'm going to show you those same three examples, and this time we're going to use substitution. So substitution follows these steps where I'm going to solve for one of the unknowns, which means I'm going to get a variable by itself, and then I'm going to plug that in to the opposite equation for that variable, solve for the variable, and then plug in my one solution into either equation to find the other solution. So remember, my solution is always an ordered pair, so I'm going to need 2 different solutions, 2 different values. So let's take a look at how this will work. Notice on this one, y is by itself. So I'm going to put a box around everything that y is equal to, and I'm going to plug that in for y in the opposite equation. So I'm going to write 2x minus, and instead of y, I'm going to substitute all of the values that y is equal to. But notice I'm just rewriting this equation with this substituted in, this expression. Now I'm going to solve because, as you'll see, I only have one variable. So I have 2x, I have minus -3x, so that's plus 3x. Again, I would probably do a ching-ching here. And then I have minus -6 or plus 6. I would subtract that 6 to the opposite side. And on the same step, combine these two values since they're on the same side. So 5x equals -5. Divide by 5 to get x is -1. Then I'm going to take that value and I'm going to plug it into either one of these equations. So I'm going to choose that first equation, and instead of x, I'm plugging in -1, but notice everything else gets rewritten. I would get the same answer if I plugged it into the other equation also. -3 times -1 is +3. 3 minus 6 is -3, and so I get the point -1, comma, -3. Remember, we always write it x, comma, y. If you'll remember when we graphed this was the solution where it actually crossed at -1, -3, so I know I did it right. Again, this equation or system of equations should look familiar. We graphed this. Let's see what happens when we solve it algebraically rather than graphically. Again, I do have a variable that's all by itself, and again, I'm using substitution. So substitution is where I get a variable alone, and I set whatever that variable is equal to, I would substitute it into the other equation. So -2x plus 4, and instead of y, I have 1/2 x minus 2 equals 8. Now I'm going to solve. I'm going to simplify. 4 times 1/2, that's 4 times 1, which is 4, divided by 2, which is 2x. 4 times -2 is -8. On the left side, I have -2 plus 2x. Those two things cancel, and I'm left with -8 equals 8. Or sometimes people add that 8 over, and they end up with 0 equals 16. Either way, this is not true. And because I ended up with something that was false, this is a no solution question. So same as before, when I graphed this, that was the two parallel lines. Notice algebraically, we'll get an untrue statement, and that's what tells us it's no solution. So of course our last one was the same line 2 times, so watch what happens here. I have all of the values that y is equal to that I'm going to plug into this equation. X plus 4 times -1/4 x plus 2 equals 8. I'm going to distribute that 4. 4 times -1 is -4, divided by 4 is -1x. 4 times +2 is 8. Just as what happened last time, x and -x canceled, and I end up with 8 equals 8. Or, of course, if I subtracted 8 from each side, 0 equals 0. Either way, this is a true statement, and when you're left with no variables, but the statement is true, this is infinitely many solutions. Infinitely many solutions. Our last method for solving a system is elimination. And in elimination, it's different. It's a different method, but we still should get the same answers. And in this method, we want both equations in the same form. So typically, we have them both in standard form. And what we're going to do is we want them to line up so that either my x values or my y values have the same coefficient and the opposite sign. So same number, opposite sign, they're additive inverses of one another. So that then when I add the two equations together, one of my variables will be eliminated. And then of course, just as we did on the last questions, we will substitute that value into either equation, write it as an ordered pair, and of course you can check your answer by plugging it into both equations. I have not done that just for the sake of time in this video. So let's take a look. Again, I'm using the same 3 equations as before, and typically I wouldn't solve a system like this with elimination because it's not in the correct form, but this will be good practice of turning things into the same form. So I'm going to rearrange this equation by adding 3x to each side, and that gives me 3x plus y equals -6. This equation, of course, is 2x minus y equals 1. Now, in this equation, if you'll notice, I already have in front of the y value, I have a +1 and I have a -1, and that's what I want. So in this one, I didn't have to do any multiplication. So what I'm going to do is I'm going to add these together. So 3x plus 2x is 5x, but +1y and -1y is 0. It cancels out. and then negative 6 plus 1 is negative 5. So now I have just one variable because my y was eliminated, and then of course it's very easy for me to solve for x, which is negative 1. Just as we did with substitution, I'm going to take the negative 1 and plug it into either equation. I can plug it into this rearranged equation or any of my originals. Again, I'm going to choose the y equals negative 3x minus 6. That gives me y equals 3 minus 6, or y equals negative 3. So just as we found in either of our other methods, our solution is still negative 1, negative 3. Solving this by elimination, again, this is not in the correct format, so I'm going to move this 1/2 x to the opposite side, which gives me negative 1/2 x plus y equals negative 2. And here I have negative 2x plus 4y equals 8. So now I want to multiply one or both of my equations by something so that either the value in front of the x or the value in front of the y is the same number but the opposite sign. So because I don't love fractions, I'm going to choose to multiply this equation. And I'm going to choose to multiply by negative 4. Now, why did I just make up negative 4? I said I want negative 1/2 x. I want to multiply it by something that will first make it positive, since this one is negative, and that's why I chose the negative. And then I said, what could I multiply by 1/2 to make it positive 2? So obviously, if I choose negative 4, half of negative 4 is negative 2, and then of course that other negative makes it positive. So watch what's going to happen now. Negative 4 times negative 1 is positive 4, divided by 2 is 2, so that leaves me with 2x. Negative 4 times positive y is negative 4y, and negative 4 times negative 2 is positive 8. I'm going to rewrite this equation because with elimination it's important that you line things up properly. And now I'm just going to add 2x and negative 2x cancels. Negative 4y and positive 4y cancels. I'm left with 0 on the left side. 8 plus 8 is 16. Again, this is not true. It's an untrue statement. It's false, which means this is no solution. So just as we had found before, this is a no solution question. And of course, our last one, using elimination, again, I'm going to add that 1/4 x to the opposite side. Notice I'm going to write it in standard form. My denominator, or my second equation, is x plus 4y equals 8. Now what I want to do is to make either the value in front of the x or the value in front of the y the same number, opposite sign. This time I'll choose the y. I'm going to take everything times negative 4, because if I take y times negative 4, I'll get negative 4y, and on the bottom I have a positive 4y. So negative 4 times 1 divided by 4 gives me negative 1x. Negative 4 times y gives me negative 4y. And negative 4 times 2 gives me negative 8. The second equation I'm going to leave exactly the way it is. And now I'm going to add the two equations together. Negative 1x plus 1x, those cancel to give me 0. Negative 4y plus 4y, those cancel to give me 0. Negative 8 plus 8, those cancel to give me 0. This is a true statement, which means infinitely many solutions. Just as we had found before, this is the one where the two lines were exactly the same.